Now, I'm going to do one with numbers that for sure involves fractions, because I know you guys love it when there's fractions involved. So we're going to do one with numbers, and then we're going to do one with letters, with fractions and letters. Like, let's see what happens. So the numbers one we're going to do, and I'm only going to use half my page. Oh, let's see. Oh, 5 wouldn't be nice. And then 3 wouldn't be nice. And -7 wouldn't be nice. There we go. Equals. There. I chose ones that when you divide things, things just get fractions all over the place, but this is, we want to do one with fractions. So first of all, when we complete the square, did we have any number in front of the x squared? No. So we could get rid of that number in front of the x squared by first dividing everything by 5, which turns out so nice for the x squared, and that's where things that are nice end, because then if you divided the next one by 5, you'd have 3x over 5, or 3/5 x, and if you divided the next one by 5, you'd have 7/5 equals 0. And then in completing the square, we always took the number by itself, which is 7/5, and moved it to the other side. And this 3/5 is our hint, but it's a terrible hint, right? Look at the last one. Wasn't that 2 a nice hint? That was like, I know it's -1, right? But one of the patterns that we notice from here to here is that we always cut it in half. So it's not nice, but I could cut that in half. Cutting something in half is like multiplying by a half. We're going to get x plus 3/10. Okay, then what would have been in this space? If you multiply this out, there would be something in this space, and then we also have to add it to this side. 9 over 100, because we would square 3 over 10 times 3 over 10, get 9 over 100. So if I add 9 over 100 to this side, I would have to add 9 over 100 to this side. Isn't this great number so far? Are you liking this? What do we do with fractions? Got common denominator, and they're going to have to add them. Can you see that you could get a common denominator of 100? And this will be 140 over 100 plus 9 over 100 will be 149 over 100. Perfect. So far, so good. How do you get rid of the squared? Square root. So I get x plus 3/10. I remember the plus or minus, and the square root of this side will be 149 over 100, which we can simplify to 149. That, unfortunately, doesn't simplify any further than that. But square root of 100, we could write this over 10. And in the end, we can move the 3/10 over, which, because that has a common denominator, this is considered the simplest form. A single fraction with our square root in lowest terms, no common factors. That is our answer. Okay? As an idea, wow, almost lined up. As an idea, this was apparently, we did the same ideas we did in this one. What made it harder is the numbers didn't work out as nicely. So we had to deal with some more fractions and some more simplifying. But as far as the steps go, well, I guess this one we had to divide first. That was one extra step that we had, where we divided by 5 to get things by itself. Okay. So it just made it a little bit harder because of the numbers we were given, but the idea stayed the same. This is how mathematicians create formulas. They say, if I get really good at an idea, what would it look like if I did it and I didn't know what was in front of the x squared, and I didn't know what was in front of the x, and I didn't know what the final number was. I had this. Well, I want this x to be black. What would we do? And the reason I had done this one with fractions to begin with is I wanted to show, like, in numbers, what is the most complicated situation you could have. And this was it. That was the most complicated situation you could have, where you have a number out front, and then a whole bunch of fractions, and working with fractions all the way through. The only way I could make this one more difficult is I change my numbers to letters. And A, B, and C are some numbers, I just don't know which ones they are. What did we do as step 1 here? We did divide it by 5 to get x squared by itself. What number would we have to divide by here? We'd have to divide by 8, which works out nicely for the first one. But then I would have that number there, and that number there. I got all fractions. Is that exactly the same thing that happened with our numbers? Yes, we got fractions. What did we do next? We moved the number that was by itself to the other side. So I'll do that again here. I'm going to keep my numbers in blue. Put an equal sign here. And then I would have to subtract c over a on both sides. Here I had it negative already, so I added. And then, like, you thought 3/5 was a bad hint? Now we have b over a as our hint. Oh my goodness. And we need to do something squared, and then we have to fill in these green spaces. I can't use blue spaces because I use blue for numbers. What did you do with the 3/5? Cut it in half. So what should we do with the b over a? Cut it in half. So we're going to get a plus, and cutting it in half will give me b over 2a, which tells me what needs to go in that space. What goes in that first green space? Plus, okay, let's do the plus in black. What did we do with this 3/10? We squared it. So what are we going to have to do with this b over 2a? We're going to have to square it. So that'll be, do it in green, b squared, and 2a times 2a would be 4a squared. And if I add that on that side, I'm going to need to add the b squared over 4a squared on this side. What did we do with our fractions here? Got a common denominator and added them. We have fractions here. We have to do the same thing. What is the common denominator between a and 4a squared? 4a squared. Notice I don't have to change anything here, but on this first one, can you see that you would need to multiply the top and bottom by 4a to get 4a squared? So then I would get a common denominator of 4a squared, and on the top, I would have a positive b squared and a minus 4ac. I'm going to write the positive number first. Doesn't matter the order. You could write minus 4ac plus b squared either way. Perfect. What did we do next with our numbers? We got rid of the squared. So what do we need to do next with our numbers that look like letters? We have to square root both sides, and you would get x plus b over 2a is equal to, and here we'd have plus or minus square root and here we notice, okay, I can move the b over 2a to the other side, plus or minus, and on the top, I can't simplify that, but the bottom is a perfect square. What's the square root of 4? 2. What's the square root of a squared? A. Technically, square root of a should be absolute value of a, but this was in a big fraction. We're just going to leave it as a. You see, I have a common denominator, so I can put my fractions together over my common denominator and have negative b plus or minus the square root of b squared minus 4ac. And this is the famous quadratic formula, which is on your formula sheet. Right? If it wasn't on your formula sheet and you forgot it, you could always replicate this. You're like, maybe not. Right? When I was in high school, they had a test whether or not you were able to do that. It was like, you have to show how you get the quadratic formula from the start to the end, as on the right-hand side. Okay? The interesting thing is it's just the same steps that we do in all of our other ones. So if you knew how to complete the square to solve, you should be able to follow those steps with letters. It's just a little bit confusing because they're not actual numbers, but you still have to use all of your rules. So at the bottom of the page, you have the quadratic formula on the bottom of page 213. And we just found out how to get it. Now, what's the nice thing about the quadratic formula? I'm going to take this 5x squared plus 3x minus 7. I'm going to rewrite it here at the bottom. Was it minus 3x? No, plus 3x. If you have the quadratic formula, and you don't want to factor, and you don't want to complete the square, because you look at this one, you're like, oh, that is going to have a lot of fractions. I don't want to complete the square, because that just looks tedious. You can now say, hey, my A is 5, my B is 3, and my C is negative 7. So the answer is, directly from the formula, x would have to equal negative 3 plus or minus. B squared would be 3 squared minus 4, and A was 5, and C was minus 7, over 2 times A. And if I take this now and I simplify it, what do I get inside of my square root? 20 times 740. This will be plus 140 plus 9, 149. And 2 times 5? 10. Check it out. Very cool. We can now just take something that looks like a lot of work and plug it into the formula, and the formula tells us the right answer. And this formula works whether you can factor or not. However, sometimes the formula is still a fair bit of work. Sometimes completing the square will still be a faster option. Often factoring is the fastest option. If you can factor well, it will be the best option. But now we have a formula that if we didn't want to do our work, or we felt our work was going wrong somewhere, we could check it. We could just plug it into the formula. So let's go to example 1. On the formula sheet, very exciting. And I like example 1 because I feel example 1, these are ones where completing the square I still think is better and faster, and I'll show you why. So I'm going to use the formula on one side, and I'm going to use completing, wow, see I can't even spell, there we go, lost the square, all right, oh no, completing the square. Feel like we should have a symbol for completing the square. Doesn't that bother you that there's a little space missing? You want to complete it? There we go, that'll be our symbol for completing the square. And it even looks like a C. Oh, it's kind of like completing the square. It's the first time I've ever used that symbol, and I love it. It's really good. Okay, that's our symbol for completing the square technique. Saves us the time. I never have to write that out again for you guys. You'll know if I draw that for you. Okay, using the formula, you would say x is equal to, we go to our equation. It's important that our equation always has to be written in this form. ax squared plus bx plus c equals 0. If you have your equation written in any other form, first you'd have to rearrange it so you know what your a, your b, and your c value are. In our case, there a is 1, b is 2, c will be 7. And if there's negatives, they go along with the value as well. Okay, so now I go to my formula. Negative b, negative 2, plus or minus b squared, which will be 2 squared, minus 4, a is 1, and c is 7. I like it. Over 2. And we simplify this, we get negative 2 plus or minus the square root of 4 minus 28. You see that you'll get a negative 24 in there. And at this moment, with the quadratic formula, this is not possible. And so we would say, can't square root a negative number, there is no solution. At the bottom of your page it says no real root. Could go to those imaginary numbers, but we won't talk about them right now. Yes?
I was going to say, why can't you pull out negative 2 since it's divisible by 4?
Yeah, but you can't square out pull out a negative out of the square root because it's not possible. If you had tried doing this one with completing the square, and the reason this is not a bad one to do with completing the square is because the hint is easy. I'm pretty sure you can see that that's going to be x plus 1 squared, which if we make our spaces would be plus 1 and plus 1. You get negative 6, and then when you square root both sides, you also get the square root of a negative and can say no solution, not possible. So I'm not sure which one is shorter in this case. They're about equal. So just because you have a formula doesn't necessarily mean that that formula will make your life faster. And I really like the second example to show you that. But sometimes it definitely will. So let's go to B. And I'm going to rewrite B. So B had x squared minus 2x minus 7. So according to our formula, our A is 1, our B is minus 2, our C is minus 7. And so we would get negative, negative 2, plus or minus. When you square a negative, put it in brackets and square it, so your notation is good on your paper. Minus 4, A was 1, B is negative 7, over 2 times 1. And we get x is equal to 2 plus or minus square root of, this will be 28 plus 4, 32 over 2. Don't write these down. Okay? I'm going to start off by making some obvious mistakes. And then I'm going to make some not obvious mistakes. Okay? Here's a very obvious mistake. Okay, well, I'll even change it to red. Okay? Oh, I have a bunch of 2's. I'm going to cancel them all out and just be left with plus or minus a 3. I just got rid of all the 2's. Can I do that way? I try to make a most obvious mistake. Something should feel wrong with what I just did there, right? Can I just get rid of 2's like that? No. Someone might say, oh, but when you cancel out a 2, you're left with 1. So should I have written a 1 here and a 31 there? Okay, something feels a little bit wrong by just taking part of a number. How about this? I just cancel out the first 2's. Are we okay with that? No. You might be tempted though. Can you see yourself tempted to cancel out those 2's? They're sitting right in front. They look so tempting. Like 2 divided by 2, that's 1. Okay? But right now, this 2 is dividing everything. Okay? What happens if I just made this a 16? Is it okay now? No, because this 32 is inside of square root. So best to just leave it? Maybe, but it's not in simplest form. We have to write our answers in simplest form, which means that our radicals need to be written as mixed radicals. So first of all, this is a right step. 32 is 16 times 2. The square root of 16 is 4, so I can write that as a mixed radical as 2 plus or minus 4 root 2 over 2. And if you are going to simplify, if something, the whole thing is divided by 2, you have to divide everything by 2. So some people like to go to the next step and I'll just write a next step. Divide the first one by 2, the second one by 2. This is a final answer. If you have more than one term and it's all divided by 2, each one has to get divided by 2. Some people like to add this optional step in purple where they say, I have a 2 in common on the top. And now that I'm multiplying, I would be allowed to simplify a single 2. Some people just say, no, I don't mind dividing every term by 2 and going right to my final answer. Now we're going to do the same one with completing the square. So I'm going to go up, draw my line. The 7 over the other side, and I'm happy because this is a nice hint. Can you see that has to be -1? And my space would mean I add 1 here, then I add 1 here. So it's equal to 8. Square root both sides. Don't forget the plus or minus. Move the 1 over. And I get 1 plus or minus the square root of 8. Is this in simplest form? No. But I can change 8 to 2 root 2. And notice, that's exactly the same answer we got with the formula, which is good, right? Be wonderful if I taught you techniques and I'm like, well, the techniques give you different answers. Well, which one's right? I have no idea. Good luck. No, they should give you the same answer. In this example, the quadratic formula gets you the right answer, but it's more difficult to simplify because we had the dividing involved, right? The completing the square actually made the simplification easier. That's sometimes going to be the case. Okay, questions to circle. Circle 4, 5, and 6.